Black holes. It's like a celestial vacuum cleaner, sucking everything in its path, even light itself. But what does it take to create a black hole? It's not just about having a massive amount of matter, it's about compressing that matter into an exceedingly tiny space. Black holes can be formed in two ways. One, when a fixed amount of matter is compressed smaller and smaller until it reaches a tipping point of extreme density. This is how supernovas transform supergiant stars into black holes. And two, by continuously adding mass to an existing object until it becomes so massive that it collapses into a black hole. For instance, when two neutron stars merge, they can form a black hole. Now let's crunch some numbers using these equations: the Schwarzschild radius and the mass of the spherical object. Named after the awesome Carl Schwarzschild, this radius is the distance from the black hole center to its event horizon. And guess what? It depends solely on the mass of the black hole. The heavier the black hole, the larger its Schwarzschild radius. If we apply these equations, we find that the Schwarzschild radius of the Sun is around 3 km, while the Earth's is a mere 1 cm. Even a human has a Schwarzschild radius of around 10 raised to minus 23 centimeters. During a supernova, the powerful explosion compresses the already dense core of a supergiant star past its tipping point, creating a black hole. But what if we can't rely on such supernova strength? Well, adding more mass to an object can do the trick. The mass of an object is proportional to its density and its volume. By increasing the mass, we increase the Schwarzschild radius. But here's a mind-blowing part. The Schwarzschild radius grows faster than the actual radius of the object. For Earth made of rock, this tipping point occurs at a staggering 140 million kilometers, about the distance to the Sun. However, it is likely to cause the Earth to collapse long before reaching that point. So, if you ever dreamt of turning yourself into a black hole, you have two options. Squeeze yourself down to a size smaller than a nucleus, or become huge enough to reach beyond the Sun. Just remember, you have a different black hole tipping point due to your lower density.